You're listening to another episode of Open Source CXO, the podcast designed to share insights on how to excel in your business using technology, regardless of the industry. Host Robert Kehoe is a self-taught software developer who has grown to the role of CEO. Renowned for his collaborations with organizations such as Stanford University, Nelnet, and Louis Vuitton, he continually seeks new challenges to conquer in the world of tech. Accompanying him is Don Blackburn, a veteran COO with over 25 years of experience in cultivating diverse relationships and driving innovation in various technical projects. Each week, they'll be sitting down with some of the nation's foremost technology leaders to develop an open source playbook, drawing from their firsthand experiences in the field. Let's talk some tech.
Today, our guest is Arturo Pino. Arturo, welcome.
Thank you.
This is kind of a unique podcast for us, a little bit different. We've done a lot of CTOs, a lot of CIOs, and things like that over the history of our podcast, but I don't believe we've done anybody from the manufacturing industry. I think we're going to take a deeper dive into manufacturing and how tech kind of relates to that and how it adds to manufacturing and so forth. So with that, why don't you tell us a little bit about yourself?
Yeah, so Arturo Pino, I got my engineering degree in mechanical engineering here at UMKC in Kansas City. Originally went to University of Oklahoma for a year and then ended up graduating in 2014. And I did also do a little bit in computer science at Georgia Tech through their online program. Ultimately didn't finish that. I kind of prioritized some of the things with work and family and some other endeavors. But for the first 5 years of my career as an engineer, I was doing manufacturing process and product. And in the manufacturing world, you have kind of three different engineering titles or roles. You're either product, process, or quality. And you're working out on the manufacturing floor, standing up operations, working with operators and factory technicians, trying to make sure that you're producing good quality products, and then that the throughput, the yield and all those kinds of things are coming out. To ultimately to be profitable, but to also meet the requirements of the customer. So I spent a lot of time on the factory floor. I spent a lot of times with designers on the requirements that they were trying to drive. And the industry I worked in was aerospace, and defense. And so there was quite a bit of a focus on quality and precision, much more than high throughput. So it was a maybe smaller volume, but higher precision, higher quality kind of technologies. But lots of very unique products. And I work particularly in the polymers area, so manufacturing composites and plastics and rubber and a bunch of different components in aerospace based on those materials. And there's a lot of pressures that kind of got us to the point where manufacturers in the United States are technologically behind pretty much every other industry. And part of it's because of the capital expense that it takes to get into manufacturing, whereas, a SaaS company doesn't really have that. But regardless, throughout history, the industrial capabilities of society is what drove technology innovation. And there was kind of this interesting divergence in the late 90s, early 2000s, when the internet really came about, that the industrial side didn't keep pace with what was happening on the consumer side with the internet. And they kind of just fell behind. And that really goes back to like this series of industrial revolutions that have happened throughout history. In the manufacturing world, there's this phrase called Industry 4.0 that people talk about quite a bit. I don't know if you've heard of
Never heard of that. No.
So Industry 4.0 kind of implies that there's been 4 industrial revolutions. The first industrial revolution was in the mid-1700s to the late 1800s. This is when the steam engine and the ability to move material through large, areas allowed us to industrialize from agricultural to large industrial society. And that was the first industrial revolution that really allowed us to build trains, to build factories, to start mass manufacturing products. And that led about one of the most, transformative changes in society in human history. And it was a result primarily out of a lot of what happened during the Renaissance, a lot of discoveries that were happening that enabled us to, study science and engineering and all these new new ways of looking at the world and observing the world, the scientific method. All these things came out of the Renaissance, allowed us to have this big industrial revolution, which built cities and built, railways, built steel to build large skyscrapers, a lot of those kinds of things.
Because you could move things
Because you can move
nationwide
things
across
yeah,
tracks.
and you can make things. The second industrial revolution was at the end of the late 1800s, where electricity and generation of power really became prominent during Thomas Edison and Nikola Tesla's days. The invention of the electric motor, the invention of the internal combustion engine during the first industrial revolution allowed us to do a lot. But with the electric motor, now you could do a lot in factories. Now you could do a lot with electricity, and it really kind of scaled up our ability to industrialize because it brought about new technologies like telecommunications. We were able to set up telephone and code wires all over the world to be able to quickly communicate information, and that led into more advanced factories that had relay switches and boards and all these different solenoid systems that could turn on and off things automatically with electricity, and that sparked a substantial second revolution. It's known as the second industrial revolution, that allowed us to have the assembly line. It allowed us to have these appliances in residential areas that were previously impossible, refrigerators and stoves and toasters and microwaves and all these appliances that significantly improve the quality of life, all developed through the industrialization of that late 1800s, early 1900s. The third industrial revolution came about when the computer was invented with the transistor and allowed us to take these large factory systems running on big relay boards and just digitize that into a control chip. Before then, when you had a large factory and you were trying to make something and readjust, maybe you needed to change a machine out, there was actually a big relay board and somebody had to go and it was point-to-point wiring. So somebody had to go and rewire the whole board in order to reprogram the machine to run differently. Well, now you can just put new firmware on a computer or run a new program on a computer, and you could get all those relays to do a virtual relay. And so this brought about the programmable logic controller, PLCs, that allowed us to automate a lot of manufacturing. This is where you started to see robotic welding, where you started to see the 5-axis CNCs and 3-axis CNCs and numerical controlled lathes come about. And so this really was about automating the individual work cell, the individual work process. So if it was a welding application, you could put a welding robot to weld that robot or to weld that assembly. You needed a machine a part, rather than having a manual machinist do all the machining, you could put it in CNC and load a program and it would machine it.
So this is 80s, 90s?
Yeah, this was actually in the 60s, started in the 60s.
Really?
Yeah, the PLCs came, I think the first PLC was in 1969, and then throughout the 60s through the 80s, computers and industrials really developed.
80s really is when smaller computers really became
Well, yeah, the personal computer came through in the late 80s, but it became first prominent in the industrial world. That's really the main application for a lot of these computers was.
So they used to be on the forefront of technology. Now they've sort of fell behind.
Right.
That's kind of what I'm understanding.
Yeah, exactly. So it was actually in the 80s and 90s that this kind of started happening, because as we started automating more and more, there was a lot of social fear that we would lose jobs, that the robots would take over. You saw a lot of movies like Terminator, right? And so there was a lot of social pressure against automation and technology.
Right.
And you could say there's a lot of justification for the concerns of that. I mean, the industrial world didn't exactly have the best reputation in history at treating people well, right? And there was a lot of really bad working conditions,
sweatshops and stuff, yeah.
Right, and so
Sure.
so there was a lot of concern about that. But you could almost say that the pendulum swung too far the other direction, where we actively rejected automation and technology in the industrial world, to the point where the demand for higher wages increased, and the demand to automate and increase productivity decreased in the United States because of a lot of these social pressures. And so what ended up happening is manufacturers had to figure out how to compete internationally. We don't live in a vacuum.
Yeah.
And so there was opportunistic countries that kind of took this as an opportunity to compete. I always say that there's two levers you can really pull if you're looking at it as a nation, looking at how to compete. One of them is the wage lever, and one of them is the technology lever.
Sure.
And nations like Germany and Japan, they really went into automation. I mean, they just cranked that technology lever as high as possible, and Japan ended up being one of the best manufacturers throughout the 80s all the way up to the mid to late 2000s in the world. I mean, everybody knew if you bought a Japanese car in the 80s through the 2000s that it was going to be better than any other car. You see other nations like Vietnam or Thailand that kind of didn't adopt the technology for various reasons. So they had to turn the wage lever way down. Now we have a lot of really low income sweatshops and other facilities in those nations making a lot of textiles, and so our textile industry completely got removed. A lot of our automotive industry went to Mexico and to these other nations because of the wage. And then you have nations that did both. China primarily. I mean, they just cranked up the technology lever and cranked down the wage lever, and so they're just took over 70% of the market share in manufacturing in the world. That's where the world makes stuff, is China. And they've been able to iterate and advance throughout the last 30 years to the point where they can replicate pretty much anything that we invent in the U.S. almost instantly. Not just in manufacturing. I don't know if you saw the R1 model, DeepSeek, that came out very recently. They really know how to replicate things quickly and how to execute fast because they've been manufacturing pretty much the entire world's product and supply chain for the last 30 years.
I do find it odd they open sourced that, though.
That was strange.
Interesting.
Well, I think, there's a lot of thoughts on that.
We don't have
Very uncharacteristic.
Yeah, well,
it seems to be
what's the
uncharacteristic.
easiest way to sabotage a company that's trying to become profitable
True.
is to make it free, right?
Yeah.
True.
So that was the third industrial revolution. The fourth industrial revolution actually started in the late 90s and early 2000s, which was really the internet. The connectivity of these Industry 3.0 technologies. So you may have a robotic welder at a specific work cell doing robotic welding applications, but it's standalone. It just does its own job. Industry 4.0 is about connecting all of those technologies together and using the internet and the cloud technologies to create a network of devices that are all fully connected that give you a real-time view into your business. And not just at the hardware level of the manufacturing floor, but at the enterprise level of the business applications, right? The ERPs, the MESs, the CRMs, all these business applications that have been developing kind of like separately from the industrials. So that's really 4.0, is you have a fully connected digital factory that is tied into the rest of the business. We're not there. It's been 20 plus years that we've been in Industry 4.0, and we've barely really done much with it.
Is it because it's going to take over jobs? Is it because you'd be losing jobs?
Well, actually, that's not even the problem. I mean, if you look at the statistics from the Small Manufacturing or the Small Business Administration, 98% of all manufacturing in the United States is done by small to medium-sized businesses. 70% of those businesses have fewer than 20 employees. 89% of manufacturers, this is this Small Business Administration, 89% of those manufacturers struggle to find people to do the job. Because in addition to these pressures of pushing manufacturing offshore, we've also been telling my generation to not go into manufacturing, right? To go get a degree instead. Now, I'm very thankful that I got a degree. I got a degree in engineering, which kind of brought me back to manufacturing. But many of my generation have no interest in manufacturing. They don't want to do manufacturing. A lot of the manufacturing companies that exist today, these small businesses, are owned by the baby boomer generation, and they're getting ready to retire. And they're not looking to take on
big shifts,
massive
totally
modernization project. They'd rather either sell the business or hand it off to their kids. Well, their kids don't want it, right? Because it's not in their wheelhouse. They haven't been trained. There's no they've gone to universities to get degrees in other things, which have value, but that has left this social pressure on the manufacturing side where people just aren't getting into manufacturing. One of the things that I'm very passionate about is trying to get my generation and younger generations into manufacturing. I want to have young people in factories. The problem
was it a point for you to go into manufacturing when you started out, or did you fall into it?
I kind of fell into it. I mean, I had a few internship opportunities at other engineering companies that they would typically call consulting businesses, where they do a lot of engineering design work, designing bridges and infrastructure and those kinds of things. So there's really two worlds in engineering. There's like the consulting and design world, and then there's like the product world. On the consulting and design world, that's where you go get like an engineering professional license, where you sign off drawings and you're approving things, and you're kind of in that. It's almost like in the world of liability. You as the engineer are taking on liability. There's a lot of money in that. And then there's like the product and manufacturing world, where you're not really signing off on like a bridge design that the public is going to be used. You're designing a piece of hardware or some kind of product or a process that makes a product, and then the company takes on the liability at the product level. And so there's kind of these two different worlds. And I really gravitated towards manufacturing because I really like seeing the physical,
Building things. Yeah.
building. I like building things.
Yeah.
And then the software aspect is amazing because it really is a massive enabler in the ability to do things with hardware.
But wouldn't the positions in manufacturing now are different than what they were in the 80s, right? Because it is automated.
You'd be surprised.
Really? Because it used to be factory workers, right, that would go in and put part A and part B and you put it down the assembly line and stuff like that. But now a lot of that's automated, I would guess. So aren't the positions really dealing more with that technology than it is with...
Well, that's where we want to go. The problem is that we haven't really shifted in the last 30 years. We're still operating factories like it's the 90s. We still have...
Putting part A and part B and
part A and part B together. We still have a paper-based process they call them routings or travelers. Literally a piece of paper that travels with the parts.
That seems crazy to me. With the technology that's there.
Except the bigger companies.
Crazy.
Like the General Motors doesn't do that.
Correct. This goes back to the point about the demographics. 98% of manufacturers are small to medium-sized businesses.
And they can't afford to go to
the ones that have marketing departments that put out commercials of this super sophisticated factory with welding robots coming in and doing all that stuff. That's the less than 2% of businesses out there, right? The General Motors, the Fords, the Teslas.
Well, they're very deceptive about it because I assumed all were pretty much at that level.
No,
absolutely not.
So you're saying...
And even those businesses aren't really doing all of the manufacturing. The other thing that's happened throughout the 30 years is through kind of really more of the academic world, this theory of supply chain theory has been pervasive in manufacturing businesses pretty much the last 30 years, where the idea is that you outsource the manufacturing of products to vendors, and these vendors will then make individual products, and then you can gain massive efficiencies by distributing out the supply chain to a bunch of different vendors. And they've invented these techniques like just-in-time manufacturing, where you can eliminate a lot of your inventory costs by really not storing anything on site, or at least the minimal amount that you would actually need, and require your vendors to deliver just in time to put into the assembly. This puts a lot of pressure on vendors because if they miss, the costs accrued by the vendor can sometimes be, destructive. But because the companies like the GM or the Fords are so big, there's another vendor ready to take that contract over because they can be pretty lucrative.
Sure.
And so really, it's kind of a joke when you say made in America, but it's like really more assembled in America, because a lot of the supply chain has actually just been distributed out. Ford really doesn't, and GM really don't even own a lot of the IP associated with the electronic control units in their cars. Bosch owns a lot of that. And so the negative side of all this supply chain distribution is that a company becomes very slow moving to innovate.
Yeah.
And this is one of the reasons why Tesla is really doing so well, is because they're trying to vertically integrate as much as possible and keep things lean and efficient. They do lose out on some of the efficiencies you gain by a massive supply chain, but you gain a lot of iteration speed, being able to turn things around a lot faster. Supply chain distribution works well when the design never changes, because then you can count on really efficient, large distribution systems. But if you're trying to innovate, then you really can't have that kind of system. It's too slow. You have to fly out to a vendor, meet with their engineers or technicians to iterate on the design. You have to fly back. You have to get the drawings approved. It's a whole process. So that's kind of been another pressure that has really only the big companies that have the resources to establish that type of supply chain are the ones that you kind of see putting out the marketing materials of these super sophisticated smart factories. And they've done a great job, but these are not the big employers in the US. Even if you look at a GM, maybe there's tens of thousands. The biggest ones are in the 100,000 range of employees. But there's 12.5 million to 13.5 million people in the workforce in the manufacturing sector in the United States. Only less than 1.5 million of that is employed by companies that have more than 500 employees. Well, there's only about 3,000 companies in the United States that are 500 employees or more in the manufacturing space.
Wow.
There's over 500,000 companies that have less than 20 employees. So 70% of all manufacturing companies have less than 20 employees.
So it's how do they automate to keep up?
Yes.
And you guys at HIX are trying to help with that problem, right?
We're trying to solve it ourselves because we're a manufacturer.
Right.
Right. And so we need to solve it because we at HIX, we have anywhere between 65, well, maybe 60 to 75 people, maybe a little bit more.
So you guys are actually a little bigger than the average.
We are bigger than the average. Yeah. Yeah. If you go to a big company and you talk to some of the engineers, because I did and I worked with some of our suppliers, you go out to a supplier trip as a field engineer or product engineer or a purchase product engineer, and you're going to a lot of small companies. Yeah. You're going to some companies where it's just a guy in his garage.
Oh, wow.
Making stuff.
Okay.
There's a lot of businesses like this. There's a lot of businesses that are just run out of...
I could see why somebody like that couldn't really afford to put a lot of investment into their tech stack.
Yeah, there is no IT guy. There's no IT department. Out of 20 people... ideally, you'd have more people working on the production floor than you'd have working in the office. So you really struggle to get the technology that we need in manufacturing today. So we have all these pressures. We have, the 30 years of offshoring. We have the 30 plus years of my generation being told to go get a degree in a white collar job. Mm-hmm. We have the international challenges of competition and supply chain disruptions. And then we just have a demographics problem. We just don't have enough people to do the manufacturing. And to your point, that doesn't mean that the jobs that we want to have are, put part A and part B together and you just do that all day long. And there is some of that, but we want to automate not only the actual manufacturing operation. We want to automate the data pipelines. We want to automate the efficiencies that you gain on the Industry 4.0 level. There's a lot of processes that are still, you need a person doing it. Like assembling a wiring harness onto a dryer is you have a wiring harness that's a flexible, piece of wire, and you have to plug it into a control connector, and you have to route it through this, interesting design of sheet metal. You can spend a year trying to program a robot how to do that consistently. It's going to be very difficult.
Right.
A human can do that very effectively, and they can identify and troubleshoot issues. And if they're trained, they can be very productive. Mm-hmm. So we need a lot of people in manufacturing to still do a lot of the actual assembly and a lot of the actual manufacturing of it. There is a ton of products where you don't need a robot to be more efficient. Actually, in many cases, a robot may be less efficient because it's so difficult to program. Mm-hmm. Right. You need an engineer on staff versus a person that can just do it no problem. In 10 minutes of training, they're like, oh yeah, I'll just route this cable through here, plug it on the back side, test it, we're good to go. So there's still thousands of those types of jobs that need to be filled, but we are not even finding the people we need to fill those jobs. The real efficiencies come when you connect all these systems together. A person working in a work cell on a technology or a product that can interface with a digital interface, right? Maybe they've got a screen and they can start a work order by just touching the work order start. They do their operation. They take a digital measurement of the product that they just made to verify some quality metric. That logs into the system. They complete their operation. They put it into a barcode scanning system. They say, I've completed this. Move it to the next place. The next person barcode scans it in. They do their manual operation. Mm-hmm. It's not really the Industry 3.0 that is the big differentiator. There are some technologies where that is the case, like in machining, but in many other areas, even a person doing the job with the supplement of all of these new technologies that we have can become incredibly productive and value driving. And that's the side that we really need to focus on in the US, because if we can identify every place where a product is touched, stored, moved, and ultimately shipped, and add to that quality measurements along the way, as a manufacturing business, we can make significantly better decisions about what equipment we need to invest in, what products we need to grow, what products are causing the most warranty claims, the most defective units, the most scrap, and we can make adjustments on that. Right. That's really where a lot of the efficiency can be gained. And so that's why we're trying to integrate. We have a lot of manual operations at HIX Corporation, and there's not really a need to change. Like, we don't really see a need to bring in robots. We have a lot of people making really good quality products that are doing a great job. We've got people running brake presses, bending sheet metal. We've got people running laser machines, cutting sheet metal. We've got people welding. We have people wiring and building kits for wiring harnesses and stuff. Those are all great jobs, and we need to keep those, and we need more of those jobs. But what we really need is to make their lives easier by not having to have a piece of paper that somebody lost,
Right.
that is telling you what the next operation
you're just trying to make their job a little bit more efficient, for sure.
Right.
And just having that alone would not only make their jobs better, but it would make the business significantly more efficient and would allow us to increase wages and to grow at the same time. And then on the business side, when you have those systems in place, the types of decisions that you can make using the software and the technology that have been put in place by querying databases on every time a product has been touched and being able to see in time series or in various other metrics what the quality or what the risks are to the business, you can make decisions about what products to produce, what new products to introduce, what products to take out of circulation, what products to obsolete. You can make a lot of decisions and make the business more profitable. So that's really the opportunity that we have. And it's incredible that it's so difficult to do that because of the software systems that are out there. And this is why I think that open source has a huge opportunity to make a big impact on real people's lives every single day.
Is there any open source software that's specific to the manufacturing industry, or are you just talking about open source in general?
There's a lot
like Python, for instance, not specific.
Well, the programming language, yeah. No, there's a lot of software out there that is in the open source world that applies. Either it's a direct implementation for manufacturers, or if it just fits in the tech stack because it's networking software, right? Or it's connecting to databases. So, like one example, ERP. I was talking earlier about some of the big ERP providers. ERP is not typically found in small companies, but there are some open source options now that have been really growing fast. One of them is called Odoo. It's an open source, fully written in Python, fully open source. Now they have a SaaS, freemium model as well, so you can run it completely on your own. You can self-host it, or you can pay them for them to host it on their platform. But their entire code base is open source. That is the ERP that we are integrating at HIX. And what we've found is that we can consolidate a lot of our previous SaaS products into just our ERP system by integrating Odoo.
What does the ERP handle for a manufacturing company like HIX?
So primarily it's the order to cash flow. So you have a sales order comes in, that generates a manufacturing order, depending on if it's inventory stock or if you need to go and make the product. Then you have your manufacturing work order, which is based on a set of additional information, like your bill of materials. So you may sell a top-level product that has 10 or 20 or 30 subcomponents in it that need to be assembled. Maybe 10 of those are purchased from another supplier, and the other 20 or 30 are manufactured in-house. So the ERP system will allow you to schedule out the manufacturing orders based on the sales orders. And then that will flow down to a manufacturing order at a specific operation in a work center. So you may have your sheet metal, bending, cutting, machining steps, assembly, paint, packaging, shipping. You may have that type of operation.
And that process, I imagine, be customized depending on the product.
Right.
Okay.
Yeah, depending on the product, and each product has its own bill of material that is sourcing different products from other vendors or internally. So the ERP kind of schedules that out. It allows you to do your purchase orders. It allows you to do the accounting. So with all of these inventory transactions that are happening, the accounting needs to be followed through as well. And so the ERP will handle all the accounting.
Does it handle the inventory as well? So the inventory control. It does accounting. It's kind of all encompassing.
Exactly. And that's why these large enterprises have ERP, because it's almost impossible to run a large manufacturing organization without an ERP.
Yeah.
Right.
With a small manufacturing organization, you end up with spreadsheets or a bunch of different SaaS products and a lot of manual operations to get data out of one into the other, a lot of email-based communication, or just, I call it sneaker net. You just walk around and talk to people to get information across.
How do you guys customize the Odoo platform?
We have, and that's actually one of the things. It's not all fun and dandy and open source. There's also some challenges because there's a lot of people working on it. Everybody's kind of got a slightly different perspective and focus, and so we've found several configurations in Odoo that we wanted to adjust for our process, or for, I would say, not even just for our process, but for how manufacturing at a small business is typically done. And so because Odoo is open source, it's a plugin system, so you can write your own plugins.
Yeah.
So that's one of the things that I've been doing is integrating plugins that are focused towards manufacturing.
Got it.
My goal is to open source these as well. They're still kind of in development, but we want to just publicly make those available. If anybody is using Odoo.
Out of curiosity, why? Why not charge for that sort of thing? Or if you have something that you feel is a little bit better way of doing it, why have you guys taken that stance?
Yeah, no, that's a great question. So ultimately, our goal is to empower small manufacturers, specifically in this region, the Missouri, Kansas, Iowa, Nebraska area, because that's kind of our home. And we want to empower people, and we want to bring manufacturing back. If you kind of gatekeep the ability to do manufacturing efficiently, it's just adding to the same problem that everybody else has.
So was that Odoo's philosophy too then, by putting it out open source? Obviously, I mean they also have a
Well,
product.
I don't know if Odoo is actually specific to manufacturing. Maybe it is, but I know
No, it's not. No,
Yeah, okay, I didn't think so.
It's a general ERP, but they have a lot of manufacturing capabilities.
Got
in
it.
them.
Got it. Because it is open source, people can add on to it.
Right.
Oh, okay.
That's
Yeah. Well, ERP typically has some level of manufacturing capabilities, whether it's NetSuite or Dynamics or any of these other systems. Odoo is great because it's open source. It's very modular. You can start with it without having to integrate the whole thing. That was kind of one of those other challenges that you have with these large integrators, is that you have to integrate the entire system. But we've started using, like, for example, the CRM and help desk part of it without necessarily focusing on the inventory side yet. And
you can just use it as you need it then, and kind of
And
implement
it's still
new pieces.
customizable.
it's customizable. We're now doing all of our maintenance for all of our equipment in our factory. We have about 300 plus pieces of equipment, and we know what our preventative maintenance is for every single one of those pieces of equipment. Now it's improving over time as well. It depends on what you put into the system. But we're using the maintenance modules. And so these are some of the things that we're trying to integrate. Odoo has a lot of functionality. We don't necessarily need all of the functionality, but we also need some functionality that may not have. Every ERP system ends up having some customization capability. Odoo's is great because it's open source. And we hope to help other companies that, we've kind of selected ERP, or at least the Odoo ERP, as part of our stack. You can do a lot of things with other software, other ERP software, but that might just be a different stack, right? You may have an Acumatica or one of these others, and those are some that we looked at as well. So that's one of the technologies that we have a lot of focus in right now. But we're also looking at how do we secure our networks, and how do we have all of the infrastructure? Yeah. Do we do on-premise? Do we cloud-based? Do we have our data? Because we can self-host Odoo, or we can have it hosted on Odoo's SaaS platform. We can do all kinds of things. And then more on the operational technology side, when we're actually starting to connect all of our equipment and reading sensor data right off the PLCs to see, if a machine is on or off, what's the uptime, what's the downtime. Those are the things that we're going to get to eventually. There's a lot of open source technology out there for that. There's one company called the United Manufacturing Hub It's an open source company, but they're also providing their own services. But there's a community that has developed essentially a Kubernetes Helm chart of a bunch of open source technologies that allow you to connect to sensors, to connect to equipment, to publish that to an MQTT broker, to store that into a database for historical records. And there's a whole Discord community of people working on this together. You have Grafana for dashboards. So you can have, on a factory floor, you walk around the factory, you can see live dashboards of operations, of inventory quantities, whatever you want to have on a Grafana dashboard, backed up by a PostgreSQL database that's running on a Docker container in either on-premise or in a cloud environment. And so they've kind of really put together a very nice set of tools that you can develop, customize yourself, or you can pay them if you don't have the techniques to, or the technical skills on site to do that for you. So that's another really good one. For cloud, there's a lot of new cloud providers that are coming out using, I don't know if you're familiar with OpenStack, but it was kind of like one of the original cloud software architectures, cloud platforms, before AWS and Azure came out.
Okay, I haven't heard of them.
OpenStack is the platform, but it can be hosted by various different providers. So Canonical and Red Hat, they host OpenStack distributions. There's various. It was actually originally OpenStack was developed originally by NASA and what was the name of the company? Rack. I can't remember the name of the company that originally invented it, but anyway, they host it now. And there's another company.
Rakuten? It's not Rakuten, is it?
Not Rakuten.
Rakuten.
No, I can't remember the name. It's like Rackspace.
No,
it's like Rackspace, I think.
Oh, okay. Like an old hosting provider?
Yes.
Oh, okay. So Rackspace was one of them back in the day.
So they originally developed with NASA. They developed OpenStack.
Okay.
And so they host OpenStack.
Gotcha.
In Europe, actually, it's very common to use OpenStack as your cloud platform versus one of the American AWS or Azure or Google Cloud. So it's actually used more internationally. And telecommunications almost exclusively uses OpenStack. So all the telecom, Verizon, and all those companies use OpenStack to manage their cloud platforms. They don't host on AWS or Azure. They have their own. Well, there's some smaller companies that are kind of coming into the market that are trying to provide OpenStack on demand. And one of those is OpenMetal, which is a company, it's a US-based company, and they've got data centers here and in Europe. And they're doing some incredible work where they will give you 3 dedicated hardware nodes in their data center that you can host whatever you want at fixed cost. So you don't pay based on usage.
That's awesome.
You pay a fixed cost, 3 dedicated hardware nodes. You can get more, obviously, but that's a lot on the security side. That's a lot on reliability side, and they will manage the infrastructure for you. And so we partnered with them, and we have an OpenMetal OpenStack platform where we're hosting a lot of our technology.
Got it.
And we're actually doing some work with them to kind of do a little bit of.
So you guys actually don't host it internally. You guys use them too.
Yeah. So there's a lot of challenges with hosting on-prem.
Yeah, there are. I was going to ask you about that. Okay, that's interesting.
No, that doesn't mean that we're not doing anything on-prem. We're a manufacturing business, and typically if you're doing manufacturing, you're going to need some on-prem. Yeah. But we're trying to minimize and have a hybrid model as much as possible. I think we're also in this advantageous position where we're kind of leapfrogging a lot of the lessons learned over the last 30 years by cloud. You see a lot of people kind of trying to get off the cloud now and have more of a hybrid model. So there's kind of the pros and cons of both.
Of course.
So we've adopted a hybrid approach. We do have some on-prem stuff for our local networks, which we're trying to secure. We're actually trying to build a zero trust network architecture in our entire business. And so there's another open source technology called OpenZD that basically allows you to have an overlay network of zero trust for everything. And I don't know if you're familiar with the zero trust network architecture.
A little bit. Can you explain a little bit about what that means and why it's relevant?
So, I mean, I come, from a large aerospace defense manufacturer, and the holy grail of network architecture is zero trust, meaning that in a traditional firewall environment in a network, you have your boundary, which is your firewall, and then anything on the local network is, at least within a VLAN, assumed to be a trusted a trusted client,
Mm-hmm.
right? So if you're on that VLAN, you can typically communicate with any of the VLANs. And this is how a lot of the security vulnerabilities happen. Is you get into a network and now you're trusted.
Access to everything,
Right. So it's the old moat and drawbridge approach to managing security, which is how security has been done forever, really. Zero trust kind of takes an approach where everybody is just treated as an untrusted user. So just because you're in the facility is no different than if you were at a Starbucks on their Wi-Fi.
Gotcha.
And so the way that you can secure these networks is by essentially closing off all ports on listening devices and using what's called an overlay network. So Tailscale does something similar with the Tailscale VPNs, but then you can very explicitly have what's called a strong identity for a unique device or user based on with certificates and various other authentication protocols. But once you have so rather than a weak identity, which is essentially an IP address or a MAC address, you have a strong identity, which is a signed certificate. Where you do mutual TLS, and so the server, if it's a server, say it's a SQL server, will require, in order to access that service, the server will first require a certificate to be, so you know that it's that server, and then the client that's connecting to it will require a certificate for the server to know that that's a known client, and then the overlay network controller will handle the access to that service. So every device, every identity in the system will have a strong identity, a known identity.
Absolutely.
And so that's how so OpenZD is an open source project. They are proclaiming wanting to be like the operating system of network security. They want to be like the Linux of network security, and they want people to just build on top of what they're doing. So they've open sourced their entire stack as well. Now that's provided as a SaaS offering by NetFoundry, the developers of OpenZD. They have a discourse group that is amazing, very good community, people very helpful, very quick response times. I mean, it's just a great community of people working together to figure out how to make our businesses more secure. So we're trying to be zero trust network architecture at the foundations. We're trying to use the best and most cost effective in cloud providers for our hosting. We're trying to use open source ERP for the ability to customize, but also integrate quickly and at a cost advantage. And there's various other things that we're working on, but primarily it's open source. We're not like exclusive. We're not trying to say that there's no service and proprietary solutions out there that are valuable, because there are plenty. But they have to kind of fit within the architecture. Yeah. They at least have to have some openness to their APIs or a way to pull data. If they're just completely closed black box, it just makes it really difficult to.
No, that's absolutely true.
To integrate, yeah. So we really think that open source has a lot to offer in manufacturing. We really think that the challenges that manufacturing has faced for the last 30 years can be overcome. We don't have to drive wages down to compete internationally. We can compete and increase wages of our people while also becoming more productive by using technology. And we can do things the way that these large enterprises do things with a much smaller footprint if we use and leverage what open source has to offer.
Right. Now, one of the questions I was going to ask is, you mentioned the statistics for manufacturing companies or companies that have 20 or less employees. Everything we're talking about today, I would imagine, is extremely overwhelming for somebody who.
Well, I was going to say the same thing. How do you get that?
How do you
word
get
out?
Somebody who's they're in manufacturing. They're not, they got into the business for one reason or another. They technology is, you use technology but you're always looking for a quick way to get it done.
Right.
So to get into something like this, where it is a more open source, well, you have to install that yourself, unless you pay somebody unless you pay them to run it for you. Then all of a sudden it's like, well, okay, well, I want to be able to customize this. So maybe you got to hire a developer at that point, or work with somebody to do it. So I'd imagine that introduces a layer of it's just overwhelming for a lot of people. What do you suggest? Like, you guys are very fortunate. Obviously, HIX is very fortunate to have you and a very technology forward-thinking sort of view on all this. But I can imagine that's a big problem.
Absolutely, yeah.
So how would you recommend for the 20 and below companies? How do they get into this? How do they?
Or even
start
the other
leveraging?
100 and below companies, I guarantee. Not everybody's
I would. That's
gone out and
100%.
got an Arturo, right? I mean,
They're
everybody's
trying
still
to
struggling.
make
Yeah.
the most money they can out of their products. So
Absolutely.
investing in sort of the network and the infrastructure and all the technology, very overwhelming.
Right.
So I guess how would you suggest somebody smaller start getting into this world to make it more efficient for them?
No, that's a great question. That's one that I'm still trying to solve. I think that in the spirit of open source, building a community is kind of the first step, right?
Okay.
Get introduced into some of these concepts and then provide an example, right? To me, an example, like if you've ever cloned a GitHub repo, if there's an examples folder, that's where you start.
Yeah.
Right. And so if HIX Corporation can build the GitHub repo of what we're trying to do and provide an examples folder, which is just ourselves, and then introduce other manufacturing businesses.
You'll need a podcast then. That could be another.
Yeah, maybe. We'll see. I would really like to have people just come on site and see some of the things that we're doing. Now, we're not done yet. We still have a lot to do, and we've got a lot of work. But this is why we want to be more in the open about what we're doing. And
Is that would that be a service you guys provided to even other?
Well, I don't know if HIX particularly is looking at providing a service, but we want to be part of a community. We want to have other manufacturers that are at least maybe early adopters, that maybe they are in a position to dedicate somebody's time to start learning some of these things, and then just kind of start a snowball effect where we can start having conversations. One of the things that I've been very lucky to have is a few contacts on LinkedIn that either I've reached out to that are kind of in the same boat, because there are other manufacturers out there that are trying to do this kind of thing. But to get with them, start to build a community, and then start to communicate how to do this. One of the things that we'll kind of have to figure out is like, what's the minimum stack that you need to get started?
Yeah.
Like, do you need a full ERP rollout, or can you get going by just setting up, a VM, on Hetzner or something cheap that lets you kind of get started? How do you do that? If maybe you've got an IT guy at a manufacturing company and he primarily just does, he fixes laptops, but he's got a little bit of time to start investigating it. Maybe we can work with some of those people. And then the other one I would say is the younger generations, the people who this is like native to, at least technology.
Yeah.
One of the challenges that you have trying to hire a young person into a manufacturing company where the manufacturing company is relatively dated is the younger generations, they know they can get anything that they need access to on their phone. One pane of glass, they can check their bank account, they can check their health records, they can check their friends, they can check anything.
So they almost don't understand it when they get into a company like that. And
So they walk
what's
in
going on
and
here?
they see paper, they're like, where am I?
Exactly.
I just travel back in time.
But I think that's what's shaking. It could be shaking up, that particular world. I think, when you get introduced to a younger generation of people, they have expectations. So that
So I think it's about trying to deliver the message that manufacturing is exciting and there's a lot that is happening in it. We're with the, I think, societal and political pressures to bring manufacturing back, that creates an opportunity to communicate a new message about manufacturing. That's why, coming on this podcast, I was kind of excited because I want to talk about why we need manufacturing, right? The industrial base of a nation is really what drives its. No nation has ever just like leapfrogged the industrial part and just became a services-oriented business. You always have to have the prosperity through the industrialization. And once you start losing that, you start to see a decline. It's not too late to reverse that in the US. We can definitely bring it back. We have the best technology. Every other country follows our lead when it comes to tech. And unfortunately in manufacturing, they're kind of taking what we're doing in the tech world and applying it in manufacturing. Well, we need to do that and improve it. And so I think there's a lot of younger generations that my generation and younger, that if we can bring them into manufacturing and show them some of the opportunities that are available to start companies or to come into companies to help and that have the capacity and the native knowledge about technology to start learning some of these things, I think that is a good way to get started. And then if there's other manufacturers out there that are looking for a solution, trying to solve the same problems, reach out and we can talk about it, talk about how we're approaching it. Maybe you take a different approach. That's okay. We're kind of not specific to any of these. That's what, kind of the research I've been
But
doing.
it's a good starting point.
It's a starting point, and we may not end up looking the same in a year, right?
Yeah.
We may swap out one of these tools for another one that may suit us better. Ultimately, I think we're still evaluating a lot of different
enough.
options.
Yeah.
But
That's awesome, man.